Hello and welcome back. In this lecture we are going to discuss about how we solve ODEs using the Laplace transform. So finally we have the good news. We are going to discuss the ODEs. Okay, so let's start with the example. So our first example is solve the initial value problem. By IVP I mean initial value problem. X double prime plus 4x equal to sine 3x, and the initial conditions are the value of x at 0 is 0, the value of x, the first derivative at 0 is 0. Okay, so let's start. So our first step is always we take the Laplace transpose of our ODE. So we will take the Laplace transpose of x double prime plus 4x equal to Laplace of sine 3x. Okay. Since Laplace is linear, this is equal to Laplace of x double prime, which is s squared. In the properties of Laplace transpose, in the properties of Laplace transform, we discuss about the differentiation and the derivative. If we take the Laplace of second derivative, it's s square xs, the derivative of function xt, we are denoting it by xs, minus s times x of 0 minus x prime of 0. So this value we got for Laplace of x double prime plus Laplace of 4x, so 4 we can pull it out, and Laplace of x we are denoting it by xs. So this is Laplace of x or xt is equal to Laplace of sine 3x. So it's going to be 3 divided by s square plus 3 square, which is 9. So this over here is Laplace of sine 3x. Okay, now we know that x of 0 is 0, so the second term is 0. X prime at 0 is 0, so this term is also 0. So what we are left with is the first term s square and the last s square xs, and the last term 4xs. So we can pull out s square plus 4 times xs. Okay. And this is equal to 3 divided by s square plus 9. Let's divide by s square plus 4 to solve for xs. So we will get 3 times s square plus 4 times s square plus 9, right? Okay, so look over here. So what we do is, first we take Laplace transform, we solve for xs, and then we take Laplace inverse. So now in this step we want to take Laplace inverse. So we want to find out what is Laplace inverse of this function. So this function 3 divided by s square plus 4 times s square plus 9 doesn't belong to our table directly, so we are going to use method of partial fraction over here. So here we are going to use partial fraction. Okay, so our denominator is multiplication of two quadratic terms. For the first quadratic term, s square plus 4, we will write ax plus b divided by s square plus 4. For the second quadratic term, which is s square plus 9, we will write, sorry, not x, but I meant s, because our variable is s. For s square plus 9, we will write cs plus d divided by s square plus 9. Now we want to find out the value of a, b, c and d. So let's multiply by s square plus 4 times s square plus 9, and we will get 3 equal to as plus b. S square plus 4 will cancel out, so we will have s square plus 9 plus cs plus d times s square plus 4, because s square plus 9 will cancel out. Okay, so previously when we were discussing partial fraction, we substituted some values of s to solve this equation. This time we are going to compare the coefficients. Okay, so let's expand this equation. So the coefficient of s cube is going to be a. Okay, let's simply expand this and then we'll collect the coefficient. I don't want to confuse you guys, so let's distribute as first. So we distribute as and we will get as cube plus 9as. Then we will distribute b and we will get bs square plus 9b. Then we distribute cs, we will get cs cube plus 4 times cs. Then we will distribute our d and we will get ds square plus 4, right? Now let's collect the coefficient. The coefficient of s cube is a plus c. The coefficient of s square is b plus d. The coefficient of s is 9a plus 4c. Then we have 40. And the constant term is 9b plus 4d, and we are comparing this with 3, right? So from here, if we compare the coefficient, we get a plus c, which is coefficient of s cube, is equal to 0. b plus d is equal to 0, 9a plus 4c is equal to 0, 9b plus 4d is equal to 3, right? So if you solve these two equations, you will get a and c are equal to 0. If you solve these two equations, you have from this equation, you will get this equation implies, or from this equation you will get b is equal to negative d. If you replace b by negative d, you will get negative 9d plus 4d equal to 3. Right? So negative 5d is equal to 3. So d is equal to 3 over 5 negative. So d is 3 over 5 and b is negative of d. So b is equal to 3 over 5. So value of b is 3 over 5. So we got the values of a, b, c and d, right? Our xs now is equal to, let me write it down below there. Our xs is equal to as plus b. A is equal to 0, so b is 3 over 5 divided by, let me recheck it, s square plus 4 plus cs plus d. C is 0, s square plus 9, and we want to find out xt, so we take the Laplace inverse both sides. Laplace inverse of this term. So we take the Laplace inverse, and by linearity we can say that we can pull out, we also used linearity in this step also to distribute the Laplace inverse, and using linearity again we can pull out the constant. So 3 over 5 we can pull out times Laplace inverse of 1 over s square plus 4. We can similarly pull out negative 3 over 5 times Laplace inverse of 1 over s square plus 9. Okay. Now 1 over s square plus 4 and 1 over s square plus 9. We want to find out the Laplace inverse using our table. Okay. So if you look at it very carefully, when you have s square plus omega square, it resembles with the Laplace of sine, but then there should be an omega multiplied to it, right? So what we are going to do is we will multiply by 2 over here, and if we are multiplying by 8, we should divide also, right? Otherwise we are changing the value. So we will divide by 2. Here 3 square, so our omega is 3. So we multiply by 3 and we divide by 3. We are multiplying both numerator and denominator by 3. So now we have 3 divided by 10. Laplace inverse of the first term now is sine 2t plus, minus 3 will cancel out. We have 1 over 5 sine 3t, and Laplace inverse of xs is xt. So this is our xt, this is our solution. So this is how, using the Laplace transform, we can solve an ODE. Let's recap. So we take the Laplace, we solve for xs, and then we take Laplace inverse. So there are 3 steps involved. We take the Laplace, we solve for xs, and then we take Laplace inverse. Okay, let's do one more example, and I'm going to skip some steps this time. And okay, actually the video is going a little long, so I'll continue the next example in next video, and we will talk about the piecewise defined function. So next ODE we are going to solve for piecewise defined function. So we'll meet in next video. Till then, bye bye, take care and practice some more problems.